Hello friends, you're watching Just Think YouTube channel. If you think you understand how the world works, that the reality around you is steady and logical, well, after this video, you might start to wonder. Because today, we're going to talk about physics. The kind that totally flips our idea of reality. Quantum physics. It's not just a complicated science. It's a place where the rules act as if the universe itself is playing by different rules. Here, tiny particles can be in two places at once. Information can travel instantly across huge distances, and the very act of watching can change reality. This sounds like science fiction, but it's all been proven by experiments. Today we'll explore what quantum physics really is, why it goes against common sense, and what laws make it one of the strangest areas of science. And most importantly, we'll try to understand what all this tells us about reality itself. If you're interested in space, the universe, and the deep laws that control it, this video is for you. But if not, maybe it's best not to continue, because it's only going to get stranger. To understand quantum physics, we first need to take a step back. We're used to a world where everything follows logic. If you throw a ball, it will fly in a predictable path. If you push an object, it will move. This is the world of classical physics, a world where everything seems stable and clear. But the deeper scientists looked into nature, the stranger the picture became. When we go down to the level of atoms and particles, the usual laws stop working. This is where quantum physics begins. It's the science that studies the behavior of the smallest things in the universe. Electrons, photons, quarks. And the problem is, these things don't act at all like we expect them to. They don't have a clear position. They don't move in obvious paths. Sometimes it seems like they don't follow logic at all. But actually, they do follow rules. Just a different kind of logic. Quantum logic. In this world, you can't say exactly where a particle is. You can only talk about probability. This means that reality at its most basic level isn't fully set. And this is where the strangest part happens. As long as we don't look at a system, it can be in several states at once. But the moment we observe it, it chooses one, as if reality itself is decided at the moment of observation. And this isn't philosophy, it's the result of experiments. The most famous example is the double-slit experiment. When particles aren't watched, they act like waves. When they are watched, they act like particles. It's as if they know they're being observed. And this is just the beginning, because the laws get even weirder from here. Imagine a coin. When you flip it, it can land on heads or tails. But while it's in the air, you don't know the result. Now imagine something much stranger. The coin isn't just not decided. It's both heads and tails at the same time. This is what superposition is. In the quantum world, a particle can be in several states at once, not either here or there, but here and there at the same time. This sounds like a mistake, but experiments have proven it. Let's go back to the famous experiment with two slits. When particles pass through the slits, they act like a wave. This means that one particle goes through both slits at once. not choosing one, but going through both at the same time, as if it exists in several places at once. But at the moment of measurement, everything changes. The particle collapses into one point, into one state, and the question arises, where was it before that? The answer from quantum physics: it didn't have one position. It existed as a set of possibilities, and only observation makes it real in the usual sense. To understand this better, physicist Erwin Schrödinger proposed a thought experiment: a cat in a box. As long as the box is closed, the cat is both alive and dead at the same time. This is not a joke. It's an attempt to show how absurd quantum logic seems in our world. But at the particle level, it works. And this is where one of the strangest ideas comes in. Reality may not exist in a definite form until we observe it. And if that's the case, what does to exist even mean then? But this isn't even the strangest law, because next particles start interacting with each other over distances that can't be explained by regular physics. Imagine two particles. They interacted with each other and then flew off in different directions. One is here. The other is at the other end of the universe. It would seem they are no longer connected in any way. But quantum physics says otherwise. These particles remain connected. So much so that changing the state of one instantly affects the other, even if there are billions of miles between them, without delay, without a signal, without time, as if distance doesn't exist. This is called quantum entanglement. And it's not a guess. It has been proven by experiments. When scientists measure one particle, they instantly know the state of the other. And here's where the puzzle comes in. According to regular physics, nothing can travel faster than the speed of light. But here, information seems to appear instantly. Even Albert Einstein thought this was impossible. He called it spooky action at a distance. And for a long time, scientists thought there was a mistake in this. But experiments showed there's no mistake. Entanglement is real. It's important to clarify. This doesn't mean we can send messages faster than light, but it means something much deeper. At a basic level, particles can be part of one system, even if they are far apart in space, as if the universe isn't separated the way we think, as if everything is connected much more strongly than it seems. And here's the next question. If particles can be connected beyond space, what does that say about the very structure of reality? But it gets even stranger, because now we're getting to an effect that questions the very role of the observer. Everything up until now has sounded pretty weird, but what we're about to talk about has made scientists really think hard about what reality actually is. In quantum physics, there's a thing called the observer effect. Here's how it works. Just the act of measuring a system can change how it behaves. Let's go back to the two-slit experiment. When particles aren't being watched, they act like waves. They go through both slits at the same time and create an interference pattern. But if you try to figure out which slit a particle went through, the pattern changes. The particle starts acting like a regular object, as if it chooses a path. And this isn't a mistake with the equipment. It's been proven many times in different experiments. It feels like reality itself depends on whether we're watching it or not. But it's important to be very clear here. This isn't about human consciousness. Quantum physics doesn't say that we create reality with our thoughts. It's about interaction. Any measurement is an interaction with the system. And it's this interaction that breaks the superposition and locks in a state. But even with that clarification, the question remains. Why does the very possibility of observation change how the system behaves? Why does nature act differently depending on whether we measure it or not? There's still no final answer to this question. There are different ways to understand this. The Copenhagen interpretation says that the state is decided when measured. The many worlds interpretation suggests that all possibilities exist at the same time, but none of them fully explain it. And this is where quantum physics stops being just a science about tiny particles and becomes a science about reality. Because if observation affects the outcome, then where is the line between the observer and the world? But even this isn't the end of it. There's a rule that shows that in the quantum world, uncertainty itself is built into the very core of reality. In old-school physics, we're used to thinking that everything can be measured perfectly. If we have enough information, we can figure out where something is and how it's moving. But quantum physics breaks that idea. There's a rule called Heisenberg's uncertainty principle. It says this: you can't know both the exact spot and the exact speed of a tiny particle at the same time. The more precisely we know one thing, the less precisely we know the other. And this isn't because our tools are bad. It's not a mistake in measuring. It's just how reality works. At the level of tiny particles, nature itself doesn't give us all the information. This means we can't predict the future with perfect accuracy. We can only talk about what's likely to happen. And this is where things really change. Old-school physics says the world is set in stone. Cause leads to effect. Quantum physics says the world is all about chances. Events don't just happen for sure. They have a chance of happening. And that's why the way particles act can seem random. But it's not chaos. It's a different kind of order. An order based on probabilities. And this brings up one of the deepest questions. If, at its most basic level, reality is uncertain, what does that tell us about the world we live in? Is our reality fixed and certain, or is it just the result of a huge number of possibilities? And if everything is based on chances, where do we draw the line between randomness and rules? We've reached a point where physics once again becomes philosophy. Up until now, we've been talking about particles, experiments and theories, but everything we've seen leads to a much deeper question. What is reality? We're used to thinking that the world exists without us, that objects have clear properties, that everything is set. But quantum physics shows us something different. At a basic level, reality isn't fixed. It can be in many states at once. It can depend on how things interact. It might not be fully decided. And that changes everything, because this means the world isn't a solid thing with strict rules. It's more like a process, a system that's always changing. And then the next question comes up. if particles don't have clear properties until we measure them? What happens with more complex systems? With objects? With life? With our minds? Some ideas about quantum physics suggest that the person watching plays a key role. Others say that all possible states happen at the same time in different versions of reality. Science doesn't have a final answer yet, but it clearly shows one thing. The deeper we look into the universe, the less obvious it becomes. And maybe the most surprising discovery isn't that physics is hard, but that reality itself might be much deeper and more complex than we can ever imagine. And this brings up another question. If the very foundation of the universe is so unusual, then what does our existence within it truly mean? So, what is quantum physics? It's not just a part of science. It's a window into a world where the usual rules don't apply anymore. A world where tiny particles can be in many places at the same time. Where distance doesn't always matter. Where just watching something can change what happens. And where it's impossible to know everything, even in theory. It sounds strange, sometimes even silly. But that's how reality works at its deepest level. And maybe the most important lesson here isn't that the world is strange, but that we're only just starting to understand it. We live in a universe that follows rules, that we don't fully grasp yet. And the further we go, the more questions pop up. This isn't a weakness of science. It's its strength, because every answer opens a new door, and maybe behind that door, an even more amazing picture of reality is waiting for us. Thanks for watching until the end. If you like these kinds of topics, please give the video a like and tell us in the comments. What do you think? Is reality fixed, or is it being made? You've been watching Just Think YouTube channel, and this is just the beginning.